we're going to more specifically use the antiderivative now. Up until now, we've been putting plus a constant, and I think now you'll understand a little bit more. But you did a good job yesterday saying basically it could be any number there, right? And when you take the derivative, it's gone. And this will give you a better idea of basically how that works. So the first statement, let's just deal with the very first statement here. It says determine all of the functions that could have 2x minus 1 as its derivative. Now see, here's a lot of how the AP goes. You know how to do that problem, but do you understand what it's saying is really the issue. So they're saying that 2x minus 1 is the derivative of something. And I would like you to give me all possibilities. So take the antiderivative. Now here's why this one's hard. What's not there that you're used to seeing is the prime, right? But it's said that it's saying, well, here's some function. This function would be the derivative of what? Okay, and so they're saying it differently. So all you have to do is really take the antiderivative of that, and it's quite simple, isn't it? Well, so it's 2. You go x to the second over 2 minus x plus a constant. Yeah, the 2's will cancel, right? Which 2's? The bigger ones, right? I guess we could say it that way, right? It's kind of weird to say the bigger 2's, but so really x squared minus x plus some constant. No matter what that constant is, you're telling me if I take the derivative, I get 2x minus 1? Very true. So that right there, that's all the functions right there. That's basically called a family of functions because they all are very, very similar. The only thing that could possibly change is c. And can c be pretty much any number we want it to be? It could be a million. It could be negative 27. 102.4. Who knows? Or the ones that we're going to choose says, then graph the original function using all of those values. Now, which one's the original function, I guess, would be the question. Yeah, the one we just found. That's the original. We're going to take x squared minus x plus 0. We're going to take x squared minus x plus 1. And I'm going to help you with that because we don't want to be here all day. Plus, we're running short on time already. This is c equals 0. It's one of the originals. This is c equals 0 in red. So that's basically here. I'll write it over here in red. This is one of the possibilities, x squared minus x plus 0. In black, I will graph x squared. I think you'll get, we don't have to do all those. We'll just do a couple. X squared minus x plus, what would be my next option? 1. All right, well, let's see what happens when we do that one. That's in black. Yes. It'll actually stay inside the red one. Good question. Because they are symmetric. So green will do x squared minus x plus 2. And I'll show you how to do something like this on your calculator, but for right now, we'll just do it like this. I think you're getting the idea. We'll just do one more because I have one more color. Of course, I can get more colors, and you get the idea. They're just going to. And what if I chose negatives for C? It would just do what? Yeah, it would go outside the red and then just keep working its way. I guess you could say down. The parabola would move, right? If I chose negatives C values. Okay, so all that's happening is. So wait a minute. All 4 of those functions I just drew, all have the same derivative. Well, how's that possible? Because remember, derivative tells you slope at a particular x value, right? So you're saying if I choose any particular x value on any of those, I'm going to get the same slope? Well, let's say I chose this point. This is the same x value on all of them, right? Do all 4 of those that I just kind of highlighted have the same slope? Yeah, they do, don't they? Okay. What if I put a bunch of parabolas down below that? If I look at that same x value, they're all going to have the same slope? Yeah, that's why they're a family of functions. Okay, because they have that same derivative that's going to give you the same deal. Do they have the same y value? No, but at that x value, they have the same slope. And it doesn't matter if maybe I chose this one over here. That x, you know, or, well, maybe I should go, well, that'd be harder over there. You got to go up. But any one I choose, maybe I'll do it right here. All those have the same slope? Yeah, and they all have the same derivative. Okay, so far, until today, we haven't really said, hey, the constant could be this or that or whatever, and actually looked at it. Okay, so now today we're saying, well, what if I look at a few? What happens? And obviously, what if it ended up being x to the third plus something? Well, it'd be a cubic graph, and it would just keep doing the same type of idea. Okay. Now, what if I want you to find a very specific answer? So this could have a lot of answers, right? Could have hundreds of answers. But what if I just want one of them? Basically, what I'm doing is I'm asking you to go in there and pick out, say, the green one, or go in there and pick out the blue one. Or maybe I'm asking you to go in and pick out a red one, or maybe even go in and pick out one we haven't even drawn. Because there's a lot of them, right? So what I need to do is give you a little bit more information. So here I'm saying determine the particular. This here is a general solution, this x squared minus x plus c. That's very general. Could be anything, right? This is going to be very particular. I'm saying there is your derivative. It's 1 over x squared. The initial condition, what do you notice is no longer on this f over here? The prime is no longer on there. So this f prime is talking about the derivative. This f over here is talking about the original. Very good. Well, obviously we know we got to do the general solution first. Well, let's do that. And let's face it, if I take the antiderivative of a derivative, they just cancel. Does that make sense? They're the opposites of each other, right? So if I take the antiderivative of that side, oh, hey, how about that? I got f of x. Awesome. Equals. So I got to take the antiderivative of that side. But boy, we haven't really dealt with it in that manner yet. How have we done that? We rewrote it as x to the negative 2, right? Well, we can integrate that. So, up a power, negative 3. Okay, just seeing if you're awake. Some of you are not. Negative 1 over plus some constant, right? That, I hope you know by now, is the general solution. It's not very well cleaned up, though, is it? How could we clean that up a little bit? Yeah. Yeah, I'd say negative 1 over x plus some constant. Okay? So now, well, that's good, but there could be a lot of answers there, right? And I'm asking you to pick out one of them. Now we have to figure out which one am I asking you to figure out. And so which one? Well, that's where this information comes in handy. You already told me this is information about the original, right? And this is telling me which one of them to pick out. Because apparently only one of them actually goes through that point. But that's a very weird way for me to write a point, isn't it? Could you write that as an ordered pair for me somehow? How would you do that? Yeah, it's 1 comma 0. Very good, right? Because it's saying put 1 in for some x value and it's going to spit out some y value, right? So down here, which one can kind of be interchanged with y? That f of x, right? And y are somewhat, you know, replaceable, right? And so what we're being told is it better, when I substitute 1 in, I better get 0. Well, let's find out what we got to do. So when I plug 1 in right there, this is supposed to say what? So do you realize that c is now the only variable left? So we're solving for c. Okay. So we know that if I put 0, if I put 1 in there, right? And there's still plus constant. So I put 1 in for where x was. I know the y value better be 0 when I'm done. It has to be that way. And according to this, there's only one possibility for c. And that is, can everybody see if I just add the 1 over, it's c equals 1, okay? Right? So what they're saying is the very specific answer that I'm looking for, and I have no room, but we'll put it here. Very good. A lot of people just tell me C at that point, and I'm not looking for C necessarily. I want the function that makes all of this happen. Not only the function that has this as a derivative, but also the function that has that as a point. And according to this, how many are there in this particular situation? There's one. It's right there. Yes? Let's not worry about two answers quite yet, but I do understand your question. The question was, is it possible to kind of get two C values? And let's not worry about that for right now. Okay, great question though. Obviously, if we're going to worry about it, it was a good question. Okay. So let's recap. This right here is the. So then I found a what did I call this? Family of function or a general solution, right? So that's what you did for today in your homework, right? Or last couple days, found general solutions. Now I said, well, I'm going to tell you more so that you can get more specific and pick just one of them. And so I said, well, when I plug in 1, I better get 0. And so we did that. We plugged in 1. We said we'd get 0. What's C? You told me it was what? Okay. Determine the particular solution for if the graph of the original has to go through 2, 4. Well, that just looks weird, doesn't it? I wrote that weird just to show you something. Do you agree that's the same equation? What's dy dx stand for? Derivative, right? And all they did, or all I did, was do what? I took this dx and multiplied it up. And really, that's what you should do. And I'll get you started on this one just because the notation's a little weird. Remember in this last one when I put the little squiggle on both sides? Well, you're still doing that same thing, right? But here I'm just integrating basically 1 dy. Over here, I'm integrating 3x squared minus 1, luckily with respect to x. That's very nice. So what is the integration of 1 with respect to y? Y. Oh, that's handy, isn't it? Y equals. Now you can go ahead and integrate that, and please find the particular solution for me. That's the only part I wanted to specify for you there, because it looks a little weird, so I didn't want you to get confused. Yes? The question is, can we just leave it as dy over dx like we did before? I think that will confuse you with other things, so I'll say no. Okay? Because later on that may confuse you, so. You actually did a very complicated little technique there. There's actually a branch of calculus for that, but we'll just say do that. Okay, we won't get more technical than that. All right, let's see here. Student in the very fluorescent and very bright greenish yellow shirt. Please tell me what you got for the right side of this equation. Sometime soon would be good. Class is almost over. That's the left side is y. You didn't say that. Which one? This one? Why? What, that top 3 and this bottom one? Oh. So apparently our original function is this. Oh, plus a constant. Is that a general solution or a particular solution? Very general, because you could pretty much put in whatever you want, as long as it's just a number. You can't put in a variable, right? That changes things. So there's your job, but I said particular. And I said it's got to go through 2, 4. And so wherever you see an x, you're going to put 2. Wherever you see y, you're going to put, wherever you find c, well, you got to figure it out, right? So y is a 4, 2 to the third minus 2 plus that, right? We don't know what it is yet. That's our whole idea, to figure that out. So we've got, I'll work it up here. 4 equals 8 minus 2 plus a constant. 4 equals 6 plus a constant. Subtract 6. C is -2. So is C equaling -2? Is that your answer? Now that, I mean, that could be an answer to a problem, but not this one. What you have to do is you have to replace it. Okay? So erase that. Put -2. That's the answer I want, because it has that for a derivative, and it goes through that point. It does both, not just one. Okay? The final example we're going to save for another day. Okay? Any questions on what we have here?